Okay, hi everyone. It's Nicole Gugliucci with you here this week for Learning Space. As you see, I'm all alone today. My co-host wasn't feeling well and had to back out, so it's just me. So I'm going to rely on your comments and feedback to make sure my sound's working correctly. And make sure everything is going well. So welcome to this week's Learning Space. This is when we talk about science and space education and outreach. I'm Nicole Gugliucci with CosmoQuest. You can comment. Please feel free to comment. I'm feeling a bit lonely today without my co-host. Either on the event page, if you're watching on Google+, or on my profile page if you're watching from there. Also, if you're watching on YouTube, I can get those comments as well. So the main topic that I was going to talk about today with Georgia is the next-gen science standards and where astronomy fits into that, and I will get to that in a minute. But first, I haven't done a hands-on demo in a little while. I hope you guys saw the Learning Space quickies I posted throughout the month of July. I did some hands-on activities. Well, I filmed it using Google Glass, which makes it really freeing. I can, especially when I was doing one with UV-sensitive beads. In order to get ultraviolet light, you have to go outside in the sunshine, but I was sitting at my coffee table in the house, and so I'd do the indoor part, run outside, do the outdoor part, and that was really useful having the camera strapped to my head for that. So that was pretty cool. So check those out. Those are the Learning Space quickies. They're at youtube.com/astrospherevids. They're in the Learning Space playlist there. So since I haven't done a hands-on activity in a while, I wanted to show you one involving Play-Doh. Yeah, I love Play-Doh. I've been sitting. This has been sitting on my desk for the past 20 minutes while I've been getting ready, just smelling like beautiful, wonderful. It's not opening. Play-Doh. So, oh my gosh, that brings back memories. Smell it, smell it. I dare you. Sniff the screen. Okay, so this is a little activity shared with me by my friend Rachel Beaton at the University of Virginia. She's a grad student who also works with the Dark Skies Bright Kids project. That is an after-school club that they do at elementary schools, rural elementary schools around Central Virginia. And I was around when we were brainstorming this activity, and I don't know exactly who all's worked on it. It was a bunch of people, but Rachel sent me the notes from it, so thank you for that, Rachel. And this is an interesting activity because it talks about planetary accretion. And so I really can't get the Play-Doh out of here. It's stuck, see? So this is talking about how planets and asteroids and comets and everything else in the solar system form. I'm just going to pull out chunks. And so you do this activity with a group of kids. We've done this with 3rd through 5th graders. I'll show you some pictures of the kids doing the activity afterwards. Yellow. Smells just as good. Smells like childhood. And you give each kid a color and a lump of clay or Play-Doh or whatever fun material you're working with. So it's kind of hard for you guys to see. It's down on my desk here. And I'll open up one more color just for funsies. Oh, we got a comment from Guido saying the quickie videos are great. I wish you were all going to do more of those sometime. Okay. Request accepted. I hope to be doing more as well. It's a really fun thing to do with glass. So hopefully we'll do more of those, since I think that goes a little bit better than for the live ones. Alright, so I've got a bunch of different colors of Play-Doh. You give each color to a student, and while you're talking about how planets form, you have them break up their ball of clay or Play-Doh into little tiny bits. Okay, so we're talking about the time when the sun was a baby star. It was just forming from a cloud of gas. It was collapsing and pulling in on itself. And around it was a disk of material. And this material had gas and dust, little tiny bits of rock. And so I've got a bunch of little tiny bits of this is my yellow planetary dust. So this would be one kid's pile. And I'll work on my green dust next. This stuff was all in a big disk around the forming star. And the way that we think planets formed in our solar system and around exoplanets, planets around other stars, is that the little bits, the little tiny grains, the itty-bitty tiny pieces of proto-solar system, they've got some green ones now, little green ones, there, would actually start to clump together and stick together. Now, the actual process by which this happens is kind of detailed and complicated, and we're still working out the physics of how that works. But we do see disks of material with dust and grit and tiny bits and gas around other young stars or forming stars, and so we know these disks happen, and we see disks with planets partly formed in them, and then we see solar systems like ours and like all the exoplanet systems with planets. And so we see solar systems in different stages of development. And so we think that that's pretty clear that's how that happened. So from these tiny little bits, tiny little Play-Doh bits, tiny little dust grains, that's how the planets form. So you talk to them about this while they're making their little Play-Doh bits, because just making Play-Doh bits isn't all that exciting all by itself. I'm going to see if I can put this on something so I can actually show it a little better. And so because you've given each kid one color of Play-Doh, sorry for the audio listeners, I realize you're missing out on the visuals here. Gravity, okay, we have a comment from Sylvan Westby, gravity sucks, so hopefully dust sticks. Yeah, dust, so there's probably electromagnetic forces that make it stick, as well as gravity, because, you know, gravity's, like you said, it's weak. It's a rather weak force, but there are other reasons why dust might stick together. Okay, so each of your kids has, this works, this is a good use of an iPad. Each of your kids has a color, and then they trade now their colors, so the different colors or different types of material, you could say you have silicon and you have iron, or something like that to get them thinking of the different materials. So then each kid gets a few of each color, so you've got a bunch here, and you have them, I'm going to do this without losing it all, you have them, you know, let it mix together and see they'll start to stick. So the little ones are already starting to stick together, so like the pinks are sticking to each other, and now the green ones are stuck. There's no reason why the yellow ones are bigger, that's just the ones I started with, and so they're not as good. And you mix it together, woo, and see that some of them stick and some of them get completely, you know, boop, dropped out. I've got stuff sticking here. And then as it starts to clump together, gravity kicks in. And so once it's bigger, then the gravity gets more important. And you can actually model this gravitational collapse by squishing it together. And you go, it doesn't really make that noise in reality, but I like making that noise. And so it squishes together, and you started to form a planet, a planetesimal, a little seed of a planet, made of all different types of things that were in the early solar system coming together. Now this model, the limitation of this model, of course, is that it doesn't show differentiation. It doesn't show that the heavier things sink to the bottom, sink to the center, because this little ball of clay or Play-Doh is not quite big enough to have gravitational forces become important. But it gets the idea of the first step across, and then they get a little planetesimal or baby planet that they can take home with them. Show with all the different materials that they made it from. And now, of course, I've got this so squished together I'll never be able to get it back apart. Sorry. That's my stealing from the Play-Doh closet. It's all good. I'll show you some pictures of the activity in action. Let's see, screen share. So here's an example. So these pictures are probably all also taken by Rachel Beaton. These are all from the Dark Skies Bright Kids Flickr photo collection. And I do know that they have permission slips for all of the kids in the picture, so if you're worried about that. So here is an example of them doing the activity with a bunch of students, and each student is putting together, you know, their collection of little bits from the solar system. Let's see what comes up next. They're squishing it together, and There's also a product called Crayola Foam, which I think we've used for it as well. Here's a finished product of a planet or planetesimal that a student has made. And there's a worksheet that goes with it as well. This goes in their weekly diary where they draw each stage. So they draw all the little dots and then they draw them coming together. So that's an idea of how what this activity looks like in action. And so we call this planet formation. If you want to give them the big word to impress their parents with when they go home, say it's accretion. And that is a really important concept for understanding where the planets come from. So this is a fun activity to do. You can make your own planet just the way the solar system made them. Just using clay, Play-Doh, Sloam, I think was the Crayola stuff. And give them an idea of how these things stick together and then collapse gravitationally. So that's my little planet, and I'm not giving it back. I'm hanging on to this. So, okay, so that was my little hands-on demo for today. Unfortunately, there's not a write-up of this activity. I could post a link to the photo album on Flickr to give you an idea of how it works, but I've got the notes from Rachel on how she did it, and I will be working on a more formalized lesson plan at some point down the line, so look forward to that. So that's my hands-on demo. I wanted to talk a little bit today about the next generation science standards. So I do not come from an education background. I come from a background of a scientist, but I'm learning more and more about how formal education works, both through my volunteer work with Dark Skies Bright Kids and through the work I'm doing now with CosmoQuest. And so the next generation science standards are the collaboration of 26 different states, so different educational groups in 26 states in the United States, based off of the I think it's based off of various national reports about the state of science education in the U.S., and it's meant to be a framework of what's the base level of knowledge every student in the United States should have in science. This comes on the heels of the Common Core standards. Common Core has been accepted by, I think, 48 of the 50 states. Those are math and English standards, so what that includes some reading and technical reading and writing, which connects it to the science standards. The next generation science standards were created with the Common Core very much in mind and very much linked together. So there's a website, nextgenscience.org, where you get all these colorful boxes and charts and plots of all the standards, and I realize this is a really tough thing for people to slog through. But for states that are starting to adopt the standards, this is something teachers need to get familiar with if their state's going to be adopting these standards. Like I said, 26 standards were involved in writing. 26 states were involved in writing the standards. I think 5, as of the last I heard, had officially accepted it, including Kansas. Go Kansas! Go Kansas, accepting the science standards. I live in Illinois. It's expected that the Illinois teachers will be using these standards as well. I used to work in Virginia, who are not involved in these standards, so sorry, DSBK guys. But when we discussed the Next Generation Science Standards at the Astronomical Society of the Pacific meeting a couple weeks back, Rick Feinberg of the American Astronomical Society was talking about the standards, and he said, something along the lines of, oh, and how much astronomy is there in the Next Gen Standards? And the general feeling from the audience was, oh yeah, there's none at all. There's not much. There's not enough. And I know Georgia and I looked at each other like, what? We've been working with these standards to build our curriculum materials around the astronomy projects at CosmoQuest. We know they exist. And Rick Feinberg went on to show all the astronomy standards and look, there's actually quite a bit of astronomy content in the science standards. Now, one major criticism of these standards is that there's not enough science content in general, and so the feeling may be that if there's not enough science content in general, it's not enough of anything, astronomy included. And I understand that is a pretty strong criticism of the standards. Of course, they're meant to be a baseline. They're meant to be a minimum. states can add the content to it if they wish. But there's a thread, so there are 3 different threads. I'm not going to use the official terminology of the Next Gen standards, to be honest with you, because I will just, you just get lost in the terminology and the acronyms sometimes. So I consider that there's like there's 4 threads in the Next Gen Science standards. There's life sciences, there's physical sciences, so physics and chemistry are kind of, so biology is the life sciences, physics and chemistry kind of mixed together in physical sciences. Earth and space science standards, that's where you're going to get a lot of your astronomy and geology and things like climate change. And then the 4th one is engineering, engineering design and practices. And so there's actually a lot of the STEM, the science, technology, engineering, mathematics, it's all being mixed in together now. You're getting a lot more marrying of the engineering and the science standards. Guido asks, 26 states have been working on the NGSS, what are the rest doing? So right now in the US, each state has its own set of standards. This is for, I mean, education has always been a locality-based thing in the United States. It's not handed down from the federal government. But of course, for students who move between states, this can cause an issue. And for people, with people being more mobile, students wanting to, leave high school and go to a different state for college, they're all getting these different backgrounds. So the Next Gen is an attempt to build up standards from the states up, just like they are now, but to make it more consistent across all the states. Say each state has its own standards for, better or for worse, and they're all there are different opinions of which states are better or worse as well. So that's where that comes from. Okay, so I wanted to focus on the space science and astronomy because I never really had much astronomy in school, formal education as a kid. I remember we talked about it for maybe 1 chapter, 2 chapters in middle school. So that was 7th grade for me. And then it never really came up in high school. We tried to have an astronomy class, but there wasn't enough interest. Weren't enough people signed up to run the class. And so, very sadly, I never had much of a formal astronomy education. I went to school in New York State, and so that was not part of the Regents' exams. I had a really good physics education, but astronomy just wasn't considered important. It wasn't part of the standards. Whereas space science and astronomy, I think is getting a little bit more focus in these standards. The other state I'm a little familiar with are the Standards of Learning, or the SOLs, great acronym, in Virginia. They're looking at the elementary standards for the purpose of Dark Skies, Bright Kids stuff, and there's not very much in the elementary standards. So my experience, there has not been much astronomy content in schools. From what I've seen, is usually if there's a teacher who's particularly personally interested in astronomy, they can get that going in their school, but that's not always a given. So there are certain core ideas in astronomy. So I will show you what one of these charts looks like. Although, yes, so if you've been looking at the standards at all, you've seen this a ton of times, and you may not want to see it again. It's very information dense. There's lots of bullet points and things that link to each other. But basically, for each grade level, there's different standards, and each one of these is broken down further. But then you look at the disciplinary core ideas, and so right off the bat in 1st grade in the Next Gen standards, it's expected that you're talking about the universe and its stars. So universe and its stars right there, observing the sun, moon, and stars, and seeing the patterns in the sky. So right off the bat, in early elementary school, we are teaching kids to look at the sky and look at the patterns. And then that gets, space science gets expanded on a little bit more in 5th grade. So if you look at the 5th grade, there's something about gravitational forces and interactions, and the apparent brightnesses of the sun and stars, so the fact that the sun is just another star. And there's a lot of things like representing data, doing graphs. There's even places where you want them arguing from evidence and building experiments to do things. There's a lot of focus on science and engineering procedure. Get rid of that. A lot of focus on science and engineering procedure as well. So you're getting them looking and playing and getting interested in science in a more hands-on, inquiry-based way, so that they're actually playing and experimenting and making little balls of Play-Doh that simulate baby planets, and doing stuff like that. And so early on in elementary school, there's already next-gen science standards involve some astronomy. It's, you know, patterns in the sky, and basic, you know, brightness of stars. In middle school, so the stuff I've done with CosmoQuest focuses on middle school, and I won't show you the texty, wordy screen, but there's a lot about scale model of the solar system, what the sizes are of properties in the planets in the solar system. Now, they don't expect students to just list facts about the planets and other bodies in the solar system. They want them to get more of a sense of, I guess maybe a more holistic approach to, you know, all the rocky planets are kind of like this, and they have processes like volcanism, and they have craters, and things like that, rather than specifically listing the properties of each planet. And I kind of like that approach. I took a planetary science course in college that was sort of based on that. It didn't just go, okay, today we talk about Mercury, here's the characteristics of Mercury. You kind of mix all the planets together and look at their properties. There's also lunar phases, eclipses, seasons. I think that's pretty typical in middle school anyway. I feel like phases of the moon is one of the most talked about topics in formal education, and how to get across the concept of the phases of the moon. We should dedicate a whole show to that, because that's a pretty big one. You know, it's not immediately obvious, nor is it easy to show on a piece of paper how the phases of the moon work. And so that tends to show up in the standards quite a lot. And then gravity within the solar system and galaxies. And so the concept of gravity itself is important in middle school in the next-gen standards. I got really excited when I saw the high school standards. Again, not going to show you all the texty text. But there's a specific standard that says, construct an explanation of the Big Bang Theory based on astronomical evidence of light spectra, motion of distant galaxies, and composition of matter in the universe. So right there, that one standard lets you unpack a whole lot of astrophysics and astronomy. So if this is being included in the next-gen standards, right, this is the minimum that we want all of students in the United States to know, to be able to understand. That's pretty important. I don't think cosmology gets that kind of treatment in most high schools. Again, unless you have a specific astronomy class, that's not something you would cover in a standard physics course, or definitely not in chemistry or biology. So right there, I think there's already a lot of okay, I will screen share this briefly. There's already a lot to be said about astronomy just in the high school standards, and just look at the list. So these are the 4 standards, right? This is the Big Bang one. Oh, these pop-ups are silly. These 4 standards, and then these are all the other ways in which they're specific ideas in this column. Cross-cutting concepts means things that matter in science, no matter what science you're talking about. And then science and engineering practices. And so you're having them do the math. You're having them make the models. You're having them make the arguments from evidence, and construct explanations and evaluate data and do all these things that is more akin to what scientists have to do in practice. Rather than just learning about the facts as they are. And so I'm pretty excited about that one in particular. So in addition to, so basically all of cosmology gets one big standard. So you could talk about Big Bang, you talk about, let's see, evidence of light spectra, motion of distant galaxies. You could talk about redshift of galaxies, and then that also allows you to talk about the creation of the elements. There's a separate standard all about nuclear fusion in the sun's core and how that makes radiation and the life cycles of stars. And so that's another big important thing for high school, for what's now going to be in the high school space science and astronomy standard, is students are going to be expected to know how to, how stars make energy and how all the elements are created in stars. And so I think that's a pretty cool thing that we're expecting people to know right off the bat. I've been fiddling with this Play-Doh while I've been talking, and it's completely solid color now. So I just needed to share that observation. Okay, put that down. So, so there's a lot going on here in the next gen science standards that has astronomy, that relates to astronomy. And one thing that also came up when we talked about this in the ASP session was that a lot of teachers going out into the classroom now, or people who have been teaching, may not have the astronomy background. They haven't been teaching it, it hasn't been a required part of the curriculum so far, or it's not something they ever learned in school. They didn't necessarily have the access to that either. And so this is something where the astronomy educators out there can really make a difference. There's lots of programs, teacher development programs that NASA puts out. There are teacher professional development programs in Europe as well, the Galileo Teacher Training Program. There are also resources. So we've talked about NASA Wavelength, nasawavelength.org. It's a really good resource for finding classroom activities on any topic related to stuff that NASA has done, but a lot of astronomy and space science, of course, and Earth science as well. But just having the activities isn't the only thing that matters, of course. Being able to do the professional development and being able to sit down with educators and scientists who have done that kind of work and know what's going on currently in the field is going to be really important. And so I would encourage, if teachers are starting to look at this, if your school districts are starting to look at it, of course it's going to take a few years for these things to roll out and for curricula to be developed on the state and local level. But look into these professional development opportunities. For example, like I said, NASA does a lot of them all over the country. We here at CosmoQuest, we did our first week-long professional development in June. So you get the content, you get the astronomy content and knowledge, either in lecture format or from readings or from discussion groups, and then you can actually test out and pilot the activities that you might use in your classroom. And so all this inquiry-based activities stuff exists, and so the astronomy education community has a lot to say and a lot to add and a lot to contribute to this growing movement towards the next gen standards. And so that is pretty exciting. Like I said, NASA Wavelength is the first place that popped into my head if you want to look into astronomy resources that are out there for teachers or for informal educators, anyone that wants to play around with it. We've talked about Terra Luna on here before. That is the CosmoQuest. I can bring up the webpage. The CosmoQuest. Actually, to show, if you go to cosmoquest.org/blog/educatorzone, that's where we post all of our materials. And so we've got collaborations with the Galileo Teacher Training Program, with Global Hands-on Universe, Discover the Cosmos. I know Pamela just spent a month in Europe doing all of this great educational outreach and teaching as well. But we did Terra Luna, which is the unit that does moon and Earth geology. I can screen share the page as well. That might help while I'm talking about it. So on our educator zone on CosmoQuest, Pamela talks a little bit about our new collaborations across with Europe. And then we've got Terra Luna, which is the first big lesson plan that we've worked on with all these different great moon activities. What's really cool about doing an activity, a lesson plan about the moon, is that we've got, you know, so many decades of experience exploring the moon. And so that's really cool. We're working on another one, and I can wave the paper in front of you. We will have an outline and a binder full of activities finished by DragonCon So if you happen to be at Dragon Con in Atlanta Labor Day weekend, you can play around. So we're calling it Investigate. Yes, it's corny, but I love it. I don't remember whether it was Kathy or Ellen who came up with it. These are two of our educators that work on building these lesson plans. And this is a 13-day unit on all about asteroids and small bodies in the solar system. Talk a little bit about comets, a little bit about meteors, but we really dig into asteroids because of the VESTA Mappers project. And so that's another thing we're working on as well. And then there'll be a short lesson plan to go along with the Cosmic Castaways planetarium show that we've done through the Science on the Half-Sphere project with Youngstown State University's planetarium. And so there's more educational materials coming out from our project, and just a wealth of educational materials out there. And look for those professional development opportunities. We're going to try and do some more online ones if there are people interested and committed to doing hangouts with us and doing these discussions virtually, since we know it's hard when people are spread so thin geographically. So I've wandered a bit. Want to remind you guys, if you have any questions or comments, to use the event page. So I've got a couple comments from you guys on the event page on Google+, and then also on YouTube. On YouTube if you're watching it there. So, or you can just tweet at me at Noisy Astronomer. I'm the only one on today, so I'm not even going to bother using a hashtag to talk about this. So send me any last comments. I'm going to pretty much wrap up this little discussion, not really discussion, monologue here about the next-gen standards. Go to nextgenscience.org if you're interested in what standards are coming down the pipeline, which states were involved in writing them, if you think your state is going to be involved, or get to know your own state standards as well. And I think the fact that there is quite a bit more of astronomy and space science and earth science, which I didn't even touch. There's lots of earth science which is applicable to other rocky bodies in the solar system. That these standards are out and published and available, and there for you to look at, comment on, and if you think it's something important, get involved at the local level. Get involved with your local school board. Write to your state school board. Tell them that you want to see these standards implemented. Tell them that you think this is important. And support your local science teacher. That's the other great thing. If you've got kids in school, let your science teachers know that you love what they're doing, you support them. If you can help, I mean, not all of us have the time or resources to help, but if you can help, come into your kids' class and help do an activity or something like that. I'm sure that they're always very appreciative of things like that. Guido asks, how long do you think it takes until such changes in the education system happen on a broader scale? Hopefully we're talking years. Months would be optimistic and not decades. So yes, months would be too optimistic. We got an actual proposed timeline from one of the speakers at ASP, whose name escapes me now. So he was particularly involved in California, the California Board of Education. California is probably going to accept the next-gen standards. They may add to it, add their own things on top of it, but they were involved in the writing. They'll probably adopt them. And it takes, maybe 6 months or so to go through the adoption process and just say, hey, we're going to do this. It takes another year or so to write the curricula and the specific state guidelines. And while you're doing that, you also need to do lots more teacher professional development. So it's up to the states to tell their teachers, hey, we're doing this. We expect this. We need you to do this. And so things have to filter down from the state level down to the local level as well, and get to all the teachers that way. So I think the projection was, if you create all the curricula, do the teacher professional development, and filter, and then do a first round of assessment. You have to create all the testing materials. you know, because you're not just doing the kinds of things that you can test with a multiple choice test. You want to test student science skills. That's going to take time as well. And so full implementation was looking like on the order of I remember mid 2016 being the estimate of when this would be implemented. Now, of course, that's when it gets, you know, fully implemented. It takes years for students to work through the system. So to actually see changes on the level of the science level of the population takes years more. But as far as actual implementation, they're talking a few years, not a few decades. So that is good. So Sylvan asks, is there any chance CosmoQuest will one day receive funding from the Department of Education, since all educational tasks have been transferred away from NASA to them? It's a great question. This is involving the restructuring of STEM, or science, tech, engineering, and math education in the U.S. The proposal put forth by the Office of the President has been to consolidate all these science education activities under the Department of Education to do the formal ed stuff, National Science Foundation to do education research, and the Smithsonian to do informal education. And so since NASA is not listed in there, the original plan was to zero out their EPO, Education Public Outreach, funding. We're not sure if that's happening yet. So yes, our NASA funding opportunities have gone away temporarily, at least. It's possible that it will be taken away from NASA completely. We're not entirely sure. So that would be that is one avenue for CosmoQuest to do, is to see if the Department of Education does offer grants. Now, the things we do with CosmoQuest are pretty inclusive. We do the science, we do the outreach, we do the education, and what we've done before is do one grant to NASA to cover all those things. And so would we need to propose to the Department of Education if they have the grant programs? Yes. But the formal education stuff we do is only one part of it. So that is a possibility down the line, is to try and get funding from the DOE. If they even offer that sort of thing. We're not even sure if they'll offer grants like that. So thank you, Sylvan, for that question. It is still up in the air whether that STEM restructure, how that funding restructuring is going to go forward, and whether all that good, wonderful NASA education and outreach stuff is going to get zeroed out. I hope not. Those people, I mean, yes, I am part of it, but I'm just amazed by the people that work with NASA on a day-to-day basis, and they just do such amazing work. That's something, again, if you care, write to your Congress people. I'm wearing my individual hat now telling you this. You know, if you want to write to your Congress people and tell them, you know, that you care about NASA's programs, that's a good thing to do. So, saying that as a private advocate, not as a scientist paid to do this stuff. So I have to make that disclaimer. So unless there are any other questions, I'm going to wrap up. Hello, Tom. I see a comment from Tom Richards. Let's see. So upcoming Hangouts, I want to tell you about, first of all, tonight at 8 p.m. Central, so that's 9 Eastern, the 6 Pacific, 2.5 hours from now, let's say that. No, an hour and a half from now. The Mad Art Lab, people are doing a hangout about Atheist Film Festival. So Mad Art Lab, we featured them on a previous episode of Learning Space. They do lots of cool science and art projects. So this is the STEAM idea, the adding art into the STEM fields. So they're doing a hangout at 8 p.m. Central, so an hour and a half from now. Check it out, madartlab.com. There's a link there that'll take you, I'm sure there's a link right on the front page there that'll take you to their hangout. They're talking about an Atheist Film Festival. At the same time, so check them out. At the same time, another group of friends of ours are doing a podcast called Consumption. This is through SpecFic Media, PG Holyfield. They joined us during the Hangoutathon to talk about the astronomy of the Game of Thrones series. And so anyway, they do a podcast about, you know, books, comics, games, stuff that they're working on or enjoying and viewing. So they also have a hangout at 8 p.m. Central tonight. Two of my favorite groups at the same time. So that's our not CosmoQuest related. Those are friends of CosmoQuest and their hangouts happening tonight. Tomorrow, I am very excited. We have a very special hangout happening. I can put up a graphic for this. It's called Destination Ceres. So we are going to be talking about the biggest asteroid in our solar system, also known as the dwarf planet Ceres. This is a Dawn Mission EPO hangout. It's at 1 Pacific, 4 p.m. Eastern. Tomorrow we will have two scientists who work on asteroid science with us talking about what lies beneath the dusty regolith Ceres. What do we know about Ceres already, and what do we think we're going to learn about it when the Dawn spacecraft gets there? Hopefully we will, right now we have the Asteroid Mappers Vesta edition up on the CosmoQuest site, and so hopefully one day we will have Asteroid Mappers Ceres edition once Dawn gets there and maps out that really cool place. So that's tomorrow at 1 p.m. Pacific. That's the Dawn hangout, so please join us. It'll be a good time. Our regularly scheduled hangouts after that are Friday at noon Pacific is the weekly space hangout. Fraser Kane hosts a bunch of us to talk about the space and astronomy news from the day. Sunday night at I think they're still at 9 Pacific is the virtual star party, so check out the sky through the telescopes of our amateur astronomers on Google Plus who do such amazing work. I am always in awe of their images and their work. And then Monday is Astronomy Cast. That's also at noon Pacific. So Fraser and Pamela, barring any other conflicts, they get together and record an episode of Astronomy Cast live using Google Hangouts. So check that out. And that's our schedule of hangouts for the week. If you have any questions about this episode, I encourage you to email me at noisyastronomer@gmail.com. If you have any questions about the episode, like anything particular about learning space you want to see more of, or if you have suggestions for guests you want to see on the show, I'm going to work on lining up some more guests for the show. So that is it for this week. I'm going to continue playing with my planetesimal that's turned a very strange shade of green now that I've completely mixed it. No differentiation whatsoever. But I'll put a link to the pictures of this activity on the Google Plus event page and on the YouTube channel. Yeah, I'll do that. All right, thanks everybody, and I will see you next week for Learning Space. Bye! Using Google Glass, which makes it really freeing. I can, especially when I was doing one with UV sensitive beads, in order to get ultraviolet light, you have to go outside in the sunshine, but I was sitting at my coffee table in the house, and so I'd do the indoor part, run outside, do the outdoor part, and that was really useful having the camera strapped to my head for that. So that was pretty cool. So check those out. Those are the Learning Space quickies. They're at youtube.com/astrospherevids. They're in the Learning Space playlist there. So since I haven't done a hands-on activity in a while, I wanted to show you one involving Play-Doh. Yeah, I love Play-Doh. I've been sitting. This has been sitting on my desk for the past 20 minutes while I've been getting ready, just smelling like beautiful, wonderful. It's not opening. Play-Doh. So, oh my gosh, that brings back memories. Smell it. Smell it. I dare you. Sniff the screen. Okay. So this is a little activity shared with me by my friend Rachel Beaton at the University of Virginia. She's a grad student who also works with the Dark Skies Bright Kids project. That is an after-school club that they do at elementary schools, rural elementary schools around Central Virginia. And I was around when we were brainstorming this activity, and I don't know exactly who all's worked on it. It was a bunch of people, but Rachel sent me the notes from it, so thank you for that, Rachel. And this is an interesting activity because it talks about planetary accretion. And so I really can't get the Play-Doh out of here. It's stuck, see? So this is talking about how planets and asteroids and comets and everything else in the solar system form. I'm just going to pull out chunks. And so you do this activity with a group of kids. We've done this with 3rd through 5th graders. I'll show you some pictures of the kids doing the activity afterwards. Yellow. Smells just as good. Smells like childhood. And you give each kid a color and a lump of clay or Play-Doh or whatever fun material you're working with. So it's kind of hard for you guys to see. It's down on my desk here. And I'll open up one more color just for fun. Okay, hi everyone. It's Nicole Gugliucci with you here this week for Learning Space. As you see, I'm all alone today. My co-host wasn't feeling well and had to back out, so it's just me. So I'm going to rely on your comments and feedback to make sure my sound's working correctly. And make sure everything is going well. So welcome to this week's Learning Space. This is when we talk about science and space education and outreach. I'm Nicole Gugliucci with CosmoQuest. You can comment. Please feel free to comment. I'm feeling a bit lonely today without my co-host. Either on the event page, or if you're watching on Google+, or on my profile page if you're watching from there. Also, if you're watching on YouTube, I can get those comments as well. So the main topic that I was going to talk about today with Georgia is the next-gen science standards and where astronomy fits into that, and I will get to that in a minute. But first, I haven't done a hands-on demo in a little while. I hope you guys saw the Learning Space quickies I posted throughout the month of July. I did some hands-on activities while I filmed these. Oh, we got a comment from Guido saying the quickie videos are great. I wish you were all going to do more of those sometime. Okay. Request accepted. I hope to be doing more as well. It's a really fun thing to do with glass. So hopefully we'll do more of those, since I think that goes a little bit better than for the live ones. All right, so I've got a bunch of different colors of Play-Doh. You give each color to a student. And while you're talking about how planets form, you have them break up their ball of clay or Play-Doh into little tiny bits. Okay, so we're talking about the time when the sun was a baby star. It was just forming from a cloud of gas. It was collapsing and pulling in on itself. And around it was a disk of material. And this material had gas and dust, little tiny bits of rock. And so I've got a bunch of little tiny bits of, this is my yellow planetary dust. So this would be one kid's pile. And I'll work on my green dust next. This stuff was all in a big disk around the forming star. And the way that we think planets formed in our solar system and around exoplanets, planets around other stars, is that the little bits, the little tiny grains, the itty-bitty tiny pieces of proto-solar system, they've got some green ones now, little green ones, yeah, would actually start to clump together and stick together. Now, the actual process by which this happens is kind of detailed and complicated, and we're still working out the physics of how that works. But we do see disks of material with dust and grit and tiny bits and gas around other young stars or forming stars, and so we know these disks happen, and we see disks with planets partly formed in them, and then we see solar systems like ours and like all the exoplanets